Hi guys, welcome to Cola Teaches Math. So today we're going to talk about the second fundamental theorem of calculus. So let's go ahead and go over the rule. So I tell my kids anytime you see an integral, an x, and a t, we're going to use the second FTC, and it's a way we're going to derive integrals. So let's go ahead and see here. We're going to derive the integral f of t dt, and when we do that, it's going to become f of u du dx. So now here's what's important. The upper bound of the integral, u, needs to be a function of x, so that needs to be our variable. And then the lower bound, c, needs to be a constant, and it can be any number we want. Okay, so that's going to be the rule when we are going to derive integrals, and all we're going to do is everywhere we see a t, we are going to replace it with the variable. All right, let's look at this first one. So d dx means derive whatever follows. So we're going to go ahead and derive the integral from 5 to x squared of e to the t sine t dt. So I see an x, an integral, and a t, so we're going to do the fundamental theorem. Checklist. The upper bound needs to be a variable, so everywhere I'm highlighting in pink, all those t's, we are now going to replace it with x squared. So we're going to have e to the x squared, sine x squared, and then we cannot forget the du dx. That means derive the variable to x. No need to simplify that. There's really nothing I can do, and that is it. So we're really not doing too much calculus. This is always the trick, and it always works. So let's look at our second example here. d dx, so we're going to derive the integral from rad x to 2, the ln of t dt. Okay, let's do our checklist. So right now, this is not good. We need the constant on the bottom. So we know a rule that says we can negate and flip the integral. So that is what I'm doing here. We're negating it and changing the bounds. And now all we're going to do is everywhere we see a t, we are going to replace it with rad x. So negative ln rad x times the derivative of rad x. If you've been watching my videos, you're in my class, remember the derivative of rad x is 1 over 2 rad x. Just memorize that. All right, and that is it. That's the answer. All right, now let's look at another one where maybe both bounds are variables. So a little bit tricky here, requires a little bit more work, but not crazy. So d dx, derive the integral from cosine x to 2x of radical t dt. Okay, first thing we need to do is we need to split up the integral. We know a rule that says we can split it up over any constant. So we're going to integrate cosine x to 0 plus integral 0 to 2x. You can choose any number you want because if you've noticed, the constant doesn't matter. That first integral needs to be negated and flipped because the 0 needs to be on the bottom. So I'm going to go ahead and do that right now in this pretty purple color. I'm just rewriting everything. And then we will apply the fundamental theorem, which means everywhere we see a t, we are going to replace that t with the variable. So we're going to have negative radical cosine x times the derivative negative sine x plus the square root of 2x times 2. So you can see right here, I'm highlighting everywhere I need to replace, and that's it.